In our previous step, we have already got the expression for our delta over here. Now we do require to remind what is the exact expression for our transfer function over there. To do that, we should erase these two non-touching loops over here, as I have already completed the loop sections over there. Now what is the transfer function analogy or expression for our signal flow graph over here? According to the Mason-Gaines formula, we do know that the transfer function is ultimately, the expression is Cs divided by Rs, which is ultimately output divided by input. And quite naturally, the expression for this one will be, as you can see that we have got two forward paths which are present over here. Now P1 that is associated with our delta 1, P1 delta 1, plus the next forward path will be P2. Now this is going to be P2 delta 2 divided by our delta. Okay, we have already got the expression for our delta over here. Now the next step will be, we should find out the expression for our delta 1 and delta 2 over here. In our previous classes, I have already told you about this delta 1, delta 2 over there. The delta 1 is quite naturally connected with our forward path over P1 over there. Now here the forward path is quite naturally our G1, G2, G1, G2, G3, G4. The expression for our delta 1 will be, if this given forward path is not touching with any other loops over there, then that is being considered as 1 minus that non-touching loops over there. Okay, if the forward path is making any type of consideration for touch with that given loop over there, then the delta 1 expression will be 1. But if any loop is present over there that is not directly touching with that forward path over there, then the expression for our delta 1 will be 1 minus that given loop over there. In this case, you can see that first do follow the path, which is this 1, G1, G2, G3, G4 and 1. Now this is our forward path, and clearly you can see that this forward path is touching with this loop of G2, and the next loop will be G3, H3, but it is not been making any touch with these two lower loops over there. Now quite naturally the expression for our delta 1 will be 1 minus our two non-touching loops that are not present for that forward path expression over there. Now these given loops are quite naturally L3 and L4. I want to repeat this portion once again. Delta 1 is directly associated with a forward path of P1 over here, and I have written the expression for our forward path, which is G1, G2, G3, G4. In our next step, we should identify that said forward path is there any loops are present that is not making any direct contact with our or direct touch with that given forward path over there. Clearly you can see that the forward path is making any touch with this given loop of G2, and the next loop will be G3, H3 over there. But in our next considered part, you can see that this is our forward path and these two loops are not touching over here, and the expression for our delta 1 will be 1 minus of that non-touching loop that are not connected with our forward path over there. And I have already written the loops over there, which are L3 and L4 over here. Now let us just put that loops over there. The L3 expression will be our G6, H6 plus L4 will be our G7, H7. This is going to be our delta 1 over there, and I should note down the expression for our delta 1 over here. The expression for our delta 1 will be 1 minus of our G6, H6 plus our G7, H7. Now the next one should be our delta 2. And similarly for our delta 2, we should consider our next forward path of our P2 over there. So let us just do the same for that P2 as well. From this expression, we have got the expression for our delta, the P1, delta 1. I have just got the expression for our delta 1. So this one is been settled. In our next part, we should focus on this P2, delta 2 over there. And we already do know the expression for our P2 over there. And if you can get the expression for our delta 2, then that will be the end of this given problem over here. Now, the P2 is directly associated with our delta 2. Okay, and what is the expression for our P2? I should write down over here. The expression for our P2 will be the forward path for our another forward path will be our G5, G6, G7 and ultimately the G8. G5, G6, G7, G8. So this is our another forward path over here, and clearly you can see that this said forward path is making a connection with this loop of L3 and L4, and there is no connection. You can do follow my finger over there, and there is no connection of this particular path or of this particular forward path with this upper two loops over there. Quite naturally, the delta 2 will be 1 minus that two non-touching loops which are present in this given problem over here, which are quite naturally named as L1 and L2. The expression will be L1 plus L2 over there, and that is the expression for our delta 2. And in the another case, if all those forward paths are touching all those loops over there, then the delta 1 delta 2 expression is gonna be 1. The value of that delta 1 delta 2 will be or 1. Now let us put that expression over here, which is 1 minus the loop for our L1 will be our G2 and loop for our L2 will be our G3H3. Now this is the expression for our delta 2 over here. I should note down the expression for our delta 2, which is 1 minus this one will be our G2 plus G3H3. Okay. Now let us just complete our expression for our transfer function over here. Just simply put all those expressions that we have already got over here. Now quite frankly, the final expression for our transfer function just by using the Masson-Gain formula will be this one. Let us just put those expressions over here. We have got the value for our P1. The P1 will be our G1, G2, G3, G4. G1, G2, G3, G4. The expression for our delta 1 will be this upper part over there, which is quite naturally 1 minus G6, H6 minus G7, H7. This one will be our delta 1 over here, and for the next part we have got plus the forward path for that next part will be our P2, which is going to be our G5, G6, G5, G6, G7, G8, and the expression for our delta 2 will be this one, which is 1 minus G2 plus G3, H3. This one will be our P1 delta 1. Quite naturally, the P1 will be G1, G2, G3, G4, and at the place of our delta 1, I have put this expression over here, which is 1 minus G6, H6 minus G7, H7. Just simply make the common of this minus, and if you just eliminate the bracket, we have got this is our final expression. And in our next part we have got the delta 2, which is the first P2 will be G5, G6, G7, G8, and this one will be a 1 minus G2, and this one will be minus. Always recheck all of your paths over there. That will be better for you to understand in a lot more meaningful way. Okay, now this is going to be our second forward path over here, which is G5, G6, G7, G8. That is directly associated with our 1 minus delta 2 will be 1 minus G2 minus of G3, H3. Now let us just put the expression for our delta over there, which is this total factor over there, which is I am just going to put down over here 1 minus our G2 minus G3H3 minus G6H6, 1 minus G2 minus G3H3 minus G6H6 minus G7H7. Okay, 1 minus G2 minus G3H3 minus G6H6 minus G7H7 plus of all those factors over here, which is plus G2 G6 H6 plus, I should continue with over here, plus G2 G6 H6 plus our G2 G7 H7, this one is being completed, plus G3 G6 H3 H6, and finally the final expression will be plus G3 G7 H3 H7. Now let us put the whole expression inside our given bracket to have the final answer over here. 1 minus G2 minus G3H3 minus G6H6 minus G7H7. If you just eliminate this bracket, just put the minus to the all those expressions, so all these expression will become minus. And for the next part we have got plus G2 G6H6 plus G2 G7H7, this one, plus G3 G6 H3H6 plus G3 G7 H3H7 over here. This is going to be our final answer for a transfer function just by using our Mission-Gaines formula. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Just do follow our classes. That is the best possible way to connect with us, and you can do understand that this channel will be huge for your future studies over there. So what are you waiting for? Please do follow our classes, do subscribe our channel, hit the bell icon for more updates, and stay tuned to the classes. Just wait for my next solution, because the next solution will be much more interesting over there. Stay tuned to the classes, do follow our videos. I am just trying to utilize this as a better platform over here, and I'm just going to say that this channel will be huge. So stay connected with us, to follow our videos. That is the best possible way to connect with this beautiful journey over here. And no other YouTube channel would like to give you this type of detailed analogies over there. I have already completed the signal flow graph, but with this additional section, your concept will be much more clearer. And you have got all those answers just by these constructive videos over there. That is all I can say over here. That's it. Thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.